Hello, and this time we're talking about geometric sequences. Geometric sequences are different to arithmetic sequences, which are the ones we normally do at GCSE. Arithmetics are the ones where you add the same amount each time, or take away the same amount each time, whereas geometric sequences are about timesing or dividing, I suppose, where you times by the same amount each time. So here I've got a few sequences, and the first one goes from 3 to 6. And if that was an arithmetic sequence, you might say, oh, let's add 3, but it doesn't work. If you add 3 to 6, you don't get 12. So once you've realized it's not an adding sequence, you can think, okay, well, 3 to 6 is timesing by 2, and then 6 to 12 is timesing by 2, timesing by 2, timesing by 2. So in order to get the next term in the sequence, you just times it again, 96. And if you want the next one, you do the same again. It doesn't have to be by a whole number, of course. So 4 to 6 is actually timesing by 1.5. Times by 1.5, times by 1.5. And so again, if you want to work out the next term in the sequence, just times by 1.5, which, because it is far too late for my brain to be doing decimals times decimals, we're just going to get the calculator out, and it is 20.25. Easy peasy. And like I said just before, you can also do it by dividing, although you don't normally think about it as dividing. So you might think about an easy one like, let's say 100, 50, 25, etc. You'd think that's half and half and half. But it's more correct to think about it as times by 0.5 or times by a half. So you still say it's times by, but you're timesing by a 0 point number, a fraction, and that will then make it go smaller. So here, to go from 100 to 80, and then 80 to 64, what is it that we're actually timesing by? Well, if you don't know what these ratios are, if you can't just see them like this one, oh, it's double, and oh, that's 1.5, you just divide it, yeah? For this one, you can just do 6 over 3, that gives you 2, and 6 over 4 gives you 1.5. So how do you turn 100 into 80? It's 80 over 100, which you can either leave as, I suppose you could do 4/5, cancel it down as a fraction, or you can have it as 0.8. So this one is times by 0.8. 80 times by 0.8, 64 times by 0.8. And again, not going to even attempt to do that in my head. 51.2 times 0.8, and the next term would be 40.96. So that's all very well and good, but if we wanted to know, let's say, the 100th term of each of these sequences rather than just the next term, then it's going to take us a long time to work out the next term, the next term, the next term, all the way up to the 100th term. So just like in arithmetic, what would be really quite helpful, although it doesn't come up in the GCSE, it is something that comes up at A level, is working out the nth term rule. And it's quite straightforward. You just have to think about your first term and then what you're doing to get the next one. So the first term here is 3, and we're going to represent that for the nth term rule for any sequence. We're going to represent that as A. Okay, so whatever the first term is, let's say it's A. In this case, it's 3, and then the next term is 6, which we got by timesing by 2. So the next term is 3 times 2. And in the nth term rule, in the general form, we're going to call this number that you times by, we're going to call this times by R. So the first term is A, the second term is AR, A times R. The third term here, 12, well, we've timesed it by 2 again. So whatever the previous term was, we now timesed it by 2, so that's 3 times 2 times 2. The previous term with an extra times 2 on, and in excuse me, and in this case we're going to just times it by R again, so it's A times R times R. So you can see that for the first term it's just A. For the second term there's 1 R. For the third term, there's 2 r's. So there's 1 fewer r than where you are. For the 50th term, there'd only be 49 r's, because that first term doesn't have an r in it, it's just the first term. So this lets us have a general form of a geometric sequence nth term rule as the first term times the common ratio, which is the amount that you're timesing by each time, to the power of n minus 1. And that will always work. So for this one, it's simply 3 times 2 to the n minus 1. That's the nth term rule. If you're ever unsure, if you want to know the 100th term, if you're unsure what the term in the sequence is, if you know where it is, so the 100th term, you're just going to do 3 times 2 to the power of 100 minus 1, or 99 in that case. And the answer is 1.9 blah 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 times 10 to the 30, so a 1 and then 30 digits afterwards. So it's pretty big. And same thing here, the first term, it's going to be 4 times 1.5 to the n minus 1, and this one is 100 times 0.8 to the n minus 1. So they all look exactly the same, it's just the first term times the common ratio, the thing you multiply by each time, to the power of 1 less than the number that you want, so n minus 1. It's pretty much all you need to know about geometric sequences until you get to A level, but we'll leave that aspect for another video. Ta-ra for now.